Hello. Today was a special day in the history of science. What happened today, among other things, was the Nobel Prize in Physics for 2023 was announced. And the recipients of this were three individuals. Their names are Anne Le Huillier, Pierre Agostini, and Ferenc Krauss, and they jointly shared this 2023 Nobel Prize in Physics for their pioneering work in developing the ability to illuminate reality on almost inconceivably brief timescales. So between the 1980s and the early 2000s, the three physicists developed techniques for producing laser pulses lasting mere attoseconds, a duration many millions of times briefer than a second. We'll come to what that is in a minute. And when viewed in such short flashes, the world slows down. So the ability to generate these attosecond pulses of light has opened the door on a tiny and extremely tiny time scale. It has opened the door to the world of electrons, says Eva Olsen, chair of the Nobel Committee for Physics and a physicist at Chalmers University. So this is really an incredible accomplishment. What we're going to talk about today is how, in fact, this was all developed thousands of years earlier, and that, in fact, we'll give evidence that in the 1990s, observations were made that are far better than the observations that were made by these Nobel laureates, but by a different technique entirely. And we want to explore that. So this is the triumph of what I'll call Eastern over Western technology. Let's go here to a particular book that is worth reading. It's called The Yoga Sutras of Patanjali. And this book was written down, no one really knows when, but at roughly around 0 AD. It consists of 195 sutras. Each of the sutras in Sanskrit is roughly 3 to 5 words. And so the entire set of Yoga Sutras can be memorized. And undoubtedly, it was memorized for thousands of years earlier, maybe even tens of thousands of years earlier, and was handed down from generation to generation. It's broken up into 4 books, each of roughly 50 sutras. So what in the West, roughly 100 years ago, Hollywood discovered was book 1 of the Yoga Sutras. This is where different postures are taught, different breathing conditions are taught so that you can relax, so that you can concentrate, so that you can meditate and tune out on the incredible noise that's all around you that distracts you from what is the true underlying reality. So that's what book 1 of the Yoga Sutras teaches you. Now, that raises the question of, well, what about the other 3 books? So if we go to book 3, we'll see roughly in sutras 25 to 30 in book 3, a variety of things happen. Once you are able to achieve this intense meditation, or some call it enlightenment, what happens is you're able to achieve other things that were simply not possible when you were distracted by the world around you. So one example is clairvoyance. Clairvoyance means to see clearly. You can see clearly down into the microcosm. That is, you can look down and down and down. Say you focus on a button on your shirt, and as you drill down and down, you'll be able to reach the level of atoms, and you'll see atoms there, and you'll realize they consist of electrons and a nucleus, and the nucleus consists of protons and neutrons. And if you drill down even more into the neutrons and protons, you'll see that they're made up of particles called quarks, and that those particles are in fact made up of subquarks. So there's, at the very bottom are these subquarks that make up the particles there, and the electrons stand by themselves. And that leads to what today physics calls the standard model of physics, of particle physics. But if you continue on down further and further, you can actually see the underlying quantization of space itself. So that space is discrete, it's made up of discrete compartments, and these subquarks hop from compartment to compartment. So the motion is discrete. The discrete particles hop from discrete compartment to complete department, and the quanta of space form a foam, and this foam is what makes up the space all around us. Now, in particular, if you go back and look at the electron in the atom, you would see this thing vibrating like crazy. It's just jittering all over the place. Werner Heisenberg in 1925, one of the true founders of what's called quantum mechanics, postulated that this Zitterbewegungen, the jittering movement of the electron, was, as the electron moves, it's jittering around its path at the speed of light. So it's incredibly fast. And if you actually go ahead and meditate, what you would find out is that you can see an electron, and one of the other things that you have is not only the ability to see the electron per se, but to control it, to actually generate forces that act on this electron, and those forces are such that you can stop the electron from jittering. You can actually get a picture of the electron. So what I'm going to do now is go to our Aleph Talks website, and there's a tab on the website. Aleph is the first letter in the Hebrew alphabet, A-L-E-P-H, and Talks is talk, so it's a play on TED Talks. And we'll see here on the Resources tab that we have the periodic table of elements, which is what quantum mechanics clarified. They explained where in the world this order of these elements came from. So on the very top left, we see the very first element, hydrogen, consists of one proton and one electron. When we go over to element number 2, helium, it consists of 2 electrons and 2 protons and 2 neutrons. And so that's the top row of this periodic table of elements. And then the next row contains 8 entities, going from lithium on over to, I can't even read it here. Anyway, the point is that the number of electrons grows as the number here, and the number of protons equals the number of electrons in each element. So that's what quantum mechanics gave us. So if you actually go down and do what Ron Cowen did in the 1990s, Ron was a Buddhist monk who learned how to do intense meditation, a la what was in the Yoga Sutras. When you go ahead and do this, what you see is that Ron is able to go down to a scale far more granular in time than the Nobel laureates that achieved with the Western technology that they employed. And what Ron did here in doing this, let's go back and just get some appreciation for the time scales we're dealing with here. We have our watches and our clocks, and they have units of seconds in them. Now we can split a second up into, say, for example, 1,000 intervals. So each of those intervals is called 1 millisecond, and in scientific notation, it's 10 to the minus 3 seconds. is the duration of each millisecond. When we split each of those up 1,000 times, we get 1 microsecond. Each microsecond is 10 to the minus 6 seconds. When we split each of those up 1,000 times, we get 1 nanosecond. So that's 10 to the minus 9th second. When we split each of those up 1,000 times, we get 1 femtosecond. That's 10 to the minus 12th seconds. And when we split up that another 1,000 times, you get 1 attosecond, which is 10 to the minus 15th seconds. The Nobel Prize was awarded to these 3 people because they were able to achieve measurements in the hundreds. The lowest number was 170 attoseconds. Ron Cowen beat that significantly, as you can see. However, Ron was only doing this through meditation, so the only thing that he could do was to take paper and pencil, and he made some sketches of what he saw. So he took an electron and he stopped it. It was no longer vibrating, a la what Werner Heisenberg talked about, but he stopped it. And what he saw was the electron, and this is the first time you'll find a picture of an electron anywhere that I'm aware of. The electron consists of 10 closed strings. These are the strings of string theory. Now, the strings themselves are vibrating like crazy, so he's able to stop those. And the energy resonates inside the cavity created by these 10 closed strings to create what we would call an electron. But the electron is really, you should think of it more as the strings containing a jelly. So it's really a quantum field that's inside the strings, and that makes up the electron. But the fields are such that the electron is a torus, it's a donut. There's a hole through the middle of it, and that's a key issue. And the electron on its surface with the strings and all of these other jelly energy entities is covered with blocks of information. The information blocks are constantly scanning, and then responding when they get a scan back. And the scan would say, well, something's changed out there. And each of these information blocks contains algorithms and data. So the algorithms say, okay, if the change is this, then I have to act accordingly. And the information blocks control the forces that are out there in nature to make those changes in fact occur. And so it goes. And so with that, what we have here is, again, something that was observed by Ron Cowen in the 1990s, and again, all through till he passed on in 2019. I worked with him from 2016 to 2019, but he was not the first one to observe this. There were undoubtedly, thousands of other people over the millennia that made these observations. They simply were not able to use the metaphors, use the languages of modern Western physics that we're using here today to describe what's going on. These observations go far beyond what was observed by the Nobel laureates today. They were, again, done with paper and pencil, so the technology is totally mental, but you have to work at this meditation to be able to achieve this. And with that, we will stop here. Have a wonderful day.